In this video, we are going to learn about RAG, Retrieval Augmented Generation. And at the end of this video, we will have a fully functional AI chatbot where we can upload PDF document and ask questions from it. And this bot will give us answer based on our document. And also in the complete process, we will visualize each of the steps of RAG. So it's going to be very interesting. Okay, so before we proceed, let me quickly give you overview about RAG, like what it is and why actually we need it. Why can't we use any sort of LLMs to do the same thing? Why we need RAG? And to answer this question, first we need to understand the limitations of LLMs. So what are the limitations of LLMs? So basically there are three main limitations of any kind of LLMs. First, up to date data. So any LLMs are trained on historical data. So it don't have information about up to date data or up to date world. So this is the first limitation, and the second limitation is it don't know about your data. Let's say in your company there are thousands of PDF and you want some answer based on that by processing those PDFs, then you cannot use any kind of LLMs to do that. So that's the other limitations of any kind of LLMs. And the third limitation is that any kind of LLMs are trained on huge amount of data. So it will not provide you niche specific knowledge. You will get answer like there are couple of possibilities, or in this case it can be this, in this case it can be that. So you will not get niche specific data, so niche specific answer. So that's the third limitation of LLMs, and with the help of RAG we can overcome all these limitations of LLMs. So now question is, what is RAG? So how it is different from LLM? So any sort of LLMs like Gemini, ChatGPT or Llama are generative models. So they will generate answers based on your question. But here in RAG, it is retrieval augmented generation. So in LLMs, they are just generation, but in RAG, it is augmented generation. So let me pull up the diagram. So this is the architecture of RAG, like how actually RAG works. And thanks to Akshay for creating this beautiful architecture. So in case of LLMs, this is the only thing that we have. We have our questions, we ask LLM and we get response. And everything like knowledge base and answer that we got from the LLM directly itself. But in case of RAG, this is the complete architecture, like starting from our document or our knowledge base, we chunk it, we create embedding vectors from our chunks and we store it in our vector database. And once user asks some question or query, we again convert those queries into embeddings and then we perform similarity search. And based on the output of the similarity search that we call context here, so based on the context plus our query, we augment the LLM, like we give LLM prompt, hey, take this context and this is the query and answer the query based on the given context. And LLM provide us answer based on the query and context. So in this way we augment the LLM. So that's why it is called augmented generation, not just generation. So this was the complete architecture of RAG. Now let's start coding our application. So this is the complete application code that we are going to understand as well as visualize. You can see these are just 170 lines of Python code. So it's going to be easy to understand, don't worry about that. And we are going to use Langchain, Streamlit and Huggingface API interface. So first, Streamlit for building the front-end application. So if you don't know about Streamlit, so with the help of Streamlit you can build data apps very quickly. And Langchain is basically a framework for developing AI applications, like applications that are powered by large language models. So we will be using it. And Hugging Face, we will be using the open source API model like Gemma. So you need to create account on Hugging Face and get your API token, because we will be using Hugging Face API token for accessing some open source models. So these are the things that we are going to use, and I have prepared all the codes already so that I don't have to waste much time by writing line by line. I will just explain step by step how RAG works. So our main purpose is to understand how RAG works by seeing it, by visualizing it step by step. So in the main function, this is the simple Streamlit application. I'm just setting the page title as doc.ai and the header of the application as doc.ai get answer based on documents. And here I'm taking the user input. And if there is some user input, then what I'm doing, I am just processing the user input from the input box, like thinking, and then handling the message send. So I will explain that later, message send part. And here is the bot, like whatever message bot will send will come from here. And this is the sidebar where we have the complete feature of uploading the PDF and clicking on process. So you can see PDF docs is equal to st.file uploader, and here we are getting PDF, and then with the st.button process button we are displaying the spinner if it is processing, and then we will perform each of the step once process is clicked. So this was the basic structure of the front end application. Like, these were the input box, this is the message by bot, these are the headers, and these are the file uploader. So you can see this is very easy to do with the help of Streamlit, and if you want to learn more about it, you can explore it by yourself. Okay, so we are done with the initial setup of UI. Now let's see the first step, like how we extract text from the PDF. So for that I have this function get text from PDF. Here what we are doing is we are getting the PDF docs from the parameter that we uploaded here. So, and from the PDF doc, with the help of PDF reader, we are breaking it into pages, and then from each of the pages we are extracting the text, and then the complete extracted text we are storing in variable called text, and we are returning as a single string from this get text from PDF. And in your case it can be like any other type of document, like markdown files or word files or SharePoint PDF URLs or any kind of online PDF URLs. So the main purpose of this function is to extract text from the documents can be anything. And to process this document, you can go here on Langchain, and here you will see a section called document loader. So here, as you can see, there are some PDF loaders. So here you can see if you have PDF URL, you can use online PDF loader and pass the URL. So the ultimate purpose of this function is to just extract text from the documents. You can have your own logic for extracting the text. So now we are clear with this get text from PDF. Now let's upload a PDF and see how we will get text from it. So I am uploading this 3-page document where this document is all about RAG only. So let's open and click on process. So as you can see, we got all the text from that PDF. So the first step, that is extraction of text, is done, and we got all our text data from the document, and we can visualize it here. Now let's see the second step. that is the creating text chunks, and that is the this step, second step. So for that I have this function get text chunks. What it will basically does, it will take character text splitter that is coming from the Langchain text splitter package. So we will use this character text splitter, and where we need to define few of the things like chunk size. So in a particular chunk, how many characters you want, and how many characters you want to overlap between chunks. So I will explain in the UI like what is overlap and why we need it. And then length function is basically the function used to calculate the size of the chunk. And once we have the splitter set, we use splitter dot split text, and we pass our complete string, and it will split and return us the chunk based on our defined set of parameters. So let's run it and visualize it. So again, I am uploading the same PDF. Click on process, and as you can see, now it is divided into 5 chunks. So we can visualize it like how our complete text breaked into 5. It is actually 6 chunks starting from index 0. So our complete text is now broken down into 6 chunks. And here you can understand overlap better. So you can see here this sentence is clipped out even without completing. So to prevent this kind of scenario where we might lost meaning of some of the sentences, we repeat last few sentences in next chunk as well. So if I will search this thing, then you will see it is also there in the next chunk, so that we will not lost any of the sentence meaning if that is clipped out or cropped in any particular chunk. So similarly, if you will go here and if you will search for this, you will get in the next chunk it as well. So that is the chunking and overlap. I hope second step is also now clear. So now we are done till here. So now we have to perform the third step from the chunk, not from the query. So first we have to perform the third step from the chunk, that is using the embedding model and creating embedding vectors and storing it in a vector database. So for that I have this function called get vector store. So it will perform basically third and fourth step both. It will create embeddings and also it will store embeddings in a vector database. So let's see the functionality of this function. So as you can see, with the help of Python and Langchain, it is very easy to do the third and fourth step. Like literally within just 5 to 4 lines of code, we are done. So here within get vector store function, we are taking all the text chunks and we are using the embedding model. So you can use OpenAI embeddings, but because it is paid, so I am using the open source free Huggingface embeddings, and I am using this model. And from the embedding model, I am using embed document function and sending our text chunks. So it will create embeddings from the chunks, and then I am using this Fice vector store. So why Fice? Because it is a local vector store that will work within our system. If you want to use some other vector store provider like Pinecone or ChromaDB, then you can also use that. But just for the demo, I am using this Fice vector store that stores our data, vector data locally. And from text, Fice dot from text, and here we are passing our complete text chunk and embeddings. And now here from this function we are returning the embeddings and vector store. Here I mentioned embeddings, so here we are not actually sending the embeddings, we are sending the embedding model. So internally it will create embedding and store it in the database. So this embedding I am just converting for the visualization purpose. So if you want, you can skip this step, but just for the visualization purpose I am returning it from here. Okay, so now I hope it's clear. We defined our embedding model, we created vector store from text and we passed text chunk plus the embedding model that we want to use. And you can use any embedding models, for example OpenAI embeddings or any open source Huggingface embeddings, and that's it. So now we are done with the third and fourth step, and here we need to understand couple of things like embeddings are different and vector database is different. Embeddings are like just the numbers, and vector database is basically full feature database, vector database, where we can have embeddings, we can delete embeddings, we can add more embeddings, we can perform similarity search, we can have metadata, we can have text chunk. So all kind of features are there in vector database, not within the embeddings. Embeddings are kind of data itself. Okay, now let's visualize it in the UI. So I'm going to upload a PDF, click on process, and as you can see, okay, I think I missed here to uncomment this line. So here we are getting vector store and vectors. So let me upload the PDF, click on process, and as you can see, for each of the chunks we have embeddings, and embeddings are nothing but the numbers. You can see huge amount of numbers, like hundreds of integer numbers for each of the index of the chunk. So you can see now these are huge amount of data, and how it is stored in the database. So this is how it looks like. So I have converted this uh, embeddings into 2D space so that we can visualize it, but in real world it can be something different because it is not actually a 3D representation, but it will give you an understanding of how vectors are stored in database. So you can see some of the vectors are closer to each other, some of the vectors are far away. So in this way vectors are stored in database. Okay, pretty cool. We visualized our vectors in our database. We see how embeddings look like, and for each of the chunk we saw all these embeddings. And now we have to do the final step, that is the taking user query and getting context from that and using LLM to get the final response. So before that, I would like to show you something interesting, like within this get vector store. So once we have vector store, we can perform kind of similarity search in this vector store. So let me write docs is equal to vector store dot similarity search. You can also perform similarity search from embeddings, but I'm doing directly similarity search from text, and internally it will convert it into embedding and perform. And k is basically number of responses we want. So internally it uses the KNN algorithm. So if you will provide k is equal to 2, then it will give you the best 2 answer. So I want best 3 answer, and let's write it in the screen so that we can see what is the output of this similarity search. So let's run it again and see what we will get for this question. What is the full form of RAG? So clear out, again upload the document, process it, and as you can see we got 3 chunks from the similarity search. So what similarity search will do, it will return us top k values. Like in our case it was 3, so it returned us top 3 text chunks where our answer might lie. So if you will search RAG, then you can see here also it is the full form of RAG, here also it is RAG, here also it is RAG. So it provided us the 3 chunks where our answer might lie. And so assume there are thousands of pages in the PDF document, then in that case it will provide us the 3 answers, so that we do not have to send all thousands of docs as a context to LLM. So that's why this similarity search is very helpful. So now you might be wondering, when we can use similarity search, then what is the purpose of using LLM? So to answer that question, assume it like this. So if user will ask what is the full form of rag, then we do not want user to see all these chunks as an answer, right? Instead, what we want the humanized, like in natural language, we want the answer. So what we will do now in the next step, now these are the context. So we will pass these context and we will take user query and we will ask LLM, hey, take these context and answer this question. So that the LLM will know, yes, I have to answer only from these context, and it will try to find the answer within this context, and if it will get relevant answer from the context, then it will provide us the answer, like the full form of RAG is retrieval augmented generation. So that's why we need LLM on top of this similarity search. So even we will like get answer, but it will not be the human readable answer or the exact answer that we want. So that's why we need the further steps where we will take the complete context plus the user query, and then it will go to LLM and it will perform the operation and will give us the final result. So again, with the help of Python and Streamlit, it's very easy to do. So let me remove this. I hope now it's clear how similarity search works and how we get the context out of our vector database. So now this get conversation chain will perform all the next step. So here I'm going to use the Google Gemma open source LLM, and LLM for LLM I'm using Huggingface endpoint, and you need to get your API token from the Huggingface. Here you can also use OpenAI LLM, and memory is basically the conversation buffer memory. So what it is the history of all the chats, like the previous answers that LLM will provide plus the previous questions that you have asked. So using the LLM plus our vector database plus our previous memory, it will create conversation chain. So this is the important thing that we need to understand. LLM plus vector database plus previous conversation, and based on that it will create the complete conversation chain and return it from here. So for example, if you will ask what is the full form of RAG, then in memory there will be nothing. So uh, okay, so there will be just your question. In memory there will be just your one question, like what is the full form of RAG. In retriever it will uh, basically take your vector database plus with your question like what is RAG, it will perform similarity search internally, and it will send it to LLM like what is the query and what is the context, and then it will get response from the LLM and create conversation chain from there. So this is the complete conversation chain that it is creating. So let's see. So I'm uncommenting this line as well. Conversation chain, and once user sends something, so handle message send, I have created this function, and inside this handle message send, so here this is how we are handling the message send, and it is basically filtering out the user question plus LLM response in a structured way. So that's the only thing happening here, and also it is handling the memory like chat history here. So finally we have our bot ready. So let's upload the new PDF file and ask some question. First let's process it. So our document is processed and we got everything, and let's quickly ask one question. Full form of RAG and why it is useful. So as you can see, we got instantly the answer. Retrieval augmented generation RAG, retrieval cutting edge approach to augmented generation. It combines distance and retrieval based and generative model, visualizing how AI system understand and generate image like text. RAG offers a factually accurate, contextually relevant, and coherent approach to generating response that are meaningful and human-like. So as you can see, we got the answer instantly. Now let's ask something else like, uh, okay, but do you know full form of it? Form of it. Okay. So I didn't told anywhere rag or something. I just called it. But based on our memory or chat history, it will know that the full form of rag is retrieval augmented generation, and I am talking about rag. So as you can see, in this way we can easily create our own uh, chatbot AI where we can upload PDF documents and ask question from it. Now let me upload one more PDF with some large data. So I have this PDF about neural networks. So this is a 1.3 MB PDF and there are, I mean, many pages. So let's process it. So it might take longer time because it is a large PDF as compared to the previous one. So as you can see here, large amount of text chunks plus, let me show you. And if you will see at the bottom, you can see we have more than 67. Okay, so we have 75 text chunks. These are embeddings and keep going. This is the vectors and these are the vectors. Literally you can see, you cannot see actually how they are located because of the density is too much. Okay, now let's ask the question like full form of ANN. Full form of ANN. So as you can see, we got the answer instantly. Now instead of writing full form of ANN, let's ask how it is useful for humans. Now it understands. Okay, so there is nothing related to ANN helpful for human. Uh, Steps involved. Let's ask something. Steps involved while working with ANN. So as you can see, it provided us 3 steps. So I hope now it's clear to you basically the complete architecture and working of RAGs, Retrieval Augmented Generation, and why we need it. Thanks for watching this video, and if you found this video helpful, make sure to like and subscribe.